I'm an architect at the New York Times, and I'll get into the story a little bit later because I'm kind of getting up there. The 51, I wish that were my age, but it's actually how many years ago I first started programming. And lately I've been looking back. Mostly generally I look forward, but that's when I got going with Fortran. And you'll see this show up every now and then because I'm going to do some flashbacks that I think are relevant to my talk. So here's the first one. That's the first computer I ever worked on. That's not me in the picture. Nice shoes, though. That was a G225, 8 KB of memory. You could look in and see the little donuts inside. I think what's interesting about this in relation to IoT is that most of the devices we'd run into in an IoT world have a lot more capacity than this machine. There's another symbol I'll use every now and then, and that's this one. And that's because I spend a lot of time diving down into rabbit holes and just looking at stuff. And that's been kind of my mode of operation at the New York Times and in previous jobs that I've had, technology evaluation at Harvard and others. And it's kind of what's Alice looking for? And I think she's going where the excitement is. I question everything. I get told. I was a Marine Corps brat, then I went to West Point, Ranger, Airborne, was in Vietnam, then went to Harvard. Really got to question everything, including authority, but go where the excitement is. Kind of tying in a little bit with data stacks, but also we're still back in time here. This is the IBM 360 at its introduction. And what was interesting about that, because it made and continued to make an enormous amount of money off of this, is that it was the first scalable architecture in hardware and enjoyed enormous success. It had 50 times scalability in the models that were introduced over the first 3 years. And the key was that this separated architecture from implementation. And as you think about Cassandra, where you got the CAP theorem, if you do a good job, they picked availability and partition tolerance and gained the scalability that we're using today. This is kind of the summary of my talk. I'm going to hit on these topics: IoT, Fabric, MQTT, Wildcard queries, query strategies, and so forth. So we'll come back to that outline as I go through the talk. So I work at the New York Times. This is kind of how I think about it. It's an old company. It's not like working for somebody new. We still do print, and it's profitable. But we're successfully transitioning to digital. I got there after retiring from IT management at the United Nations, and I really wanted to go back to tech. So they gave me a corner. They paid me every month. I've worked at a lot of startups. That's pretty nice. And we get reasonable hours. So, but one thing I found out as soon as I got there is that we don't actually produce very much content. And so I kind of think of us as like the elephant on the ball. And in my orientation, they said, you know what? We produce about a Harry Potter novel a week. And I thought, wow, for a $3 billion corporation, that's not a lot. And so, of course, we have to figure out ways to get that out. Oops, here we go back in time. Before the internet, I worked at Harvard, and we had 30,000 computers that we could reach across our internet. Now, this internet with a small I, because there was no commercial internet at that time. And those 30,000 computers were all on disparate networks: Token Ring, you name it, all kinds of networks before TCP/IP became ubiquitous. So that was our reachable internet. If we kind of jump into the rabbit hole a little bit, I was lucky. I developed a system that is really the progenitor of many systems that I've worked on that deal with messaging and databases. And I got to build a complete system called the information utility that connected all of those machines using C and DB2 on mainframe. And I wrote all the PC and Mac software too, so it was a lot of fun for me and saved Harvard a lot of money. But back to the New York Times. So if we're publishing a little bit and we've got users out there, then what comes to mind? And really, it's this. We got to be good at publish and subscribe. When I came to the Times, then sat me in the corner. I work on infrastructure. I knew a good bit about Amazon Web Services, which is why they brought me in. And, but they also gave you the license to think. And so I thought about publish and subscribe, and about that time, WebSockets started to come on the scene and become usable. And so we thought, well, what if we could take what we knew about WebSockets? It's a vague idea, which is why you've got kind of a vague slide up there. And we could sort of flatten everything out. We could come up with a way to auto-scale, make it global, make it reliable, and manageable. And I was just one guy with an idea, but they said, oh, okay, keep working on that in your spare time. So I thought, well, we need to make a mesh, a communications mesh. It's got to be resilient. It's got to auto-balance, use least latency routing, all these goodies that I had learned about in AWS. And we kept pushing on that, and we said, okay, we could put in nodes with roles, have it be self-organizing, using things like today we're moving to console as an example. But we wrote a lot of code to manage this in Python. And then what we can do is connect up using WebSockets and other messaging technologies, MQTT primarily, and put messaging everywhere. And lo and behold, we ended up with a structure which is global, spread across multiple regions, multiple zones, and looks like this. So this is the New York Times fabric, and it's really, I laugh to think about it, but I think about it as kind of just a greasy layer that distributes messages, but it's got a memory. And so you can think of all those little green dots in there as being Cassandra nodes. And so we have a cluster. Our production cluster is running in every region with data centers in those regions, spread out across the zones. And as a result, we've never had a failure. Everything else is also distributed in the same manner. This whole thing scales up and down on a daily basis at about a 5-to-1 to 10-to-1 ratio. And you can see the messaging move around the world as this happens. So this is pretty cool. So it's not just me running this. There's actually 3 of us now. And we do all the DevOps and all the development on this. But just to jump down the rabbit hole a little bit, I think this is an aspect of Cassandra that doesn't get quite enough attention, and that is that it's a staged, event-driven architecture. And I've been interested in this because our fabric uses the same kind of architecture. Asynchronous, and the key to it is it defers processing. If it doesn't have to do it, doesn't do it right away, queues it up. And so, in my experience, people get into trouble when all of a sudden compaction looks like it's going wild on them. They didn't anticipate, hints, repairs, all of these things that are kind of the deferred processing that happens. But because those things are deferred, then the response time can be fast. So if you don't know about the CETA architecture, it's worth a read. There's a nice paper on it. Wikipedia's got the link. But let's go back to this. Messaging everywhere, an asynchronous microservice architecture. So that's what we have. And again, here where we are. So that's the fabric. But what about IoT? And if there's one number you should remember, I think it's this number. It's the 50 billion number, that by 2020, there'll be 50 billion connected devices. I'm not sure whether that's the right number or whether that's a conservative number. And just to contrast, remember at Harvard, I was thinking of 30,000. Machines are roughly the equivalent of this, or what we're seeing being attached to packages, showing up in chair seats, and so on. One interesting thing, we're going to dive down the rabbit hole again, and think about is, when you have that many connected devices, what can happen? We've actually seen, well, take a look at this picture and what's wrong with that picture. And I'll tell you, this is right before the bridge fell down. And the reason the bridge fell down is because of resonance. That is, the energy coming and hitting the bridge from the wind caused it to resonate on what's called an eigenfrequency, and it resonated to destruction. We've actually seen this a couple of times in the financial world. Our colleagues that work on financial systems are often way ahead of us in terms of the velocity at which their transactions occur. And with automated trading, they get resonance. And it'll be interesting for me to see, because I've studied lattice dynamics, and we're now getting up big enough to where lattice dynamics may come to play. Okay, well, back out of the rabbit hole, we're back to this number. But how can we reason about that? How can we at the New York Times reason about IoT? What does that mean to us? And I kind of take it and I turn it around. So TOI, what's that? And I think of the things of interest. If I think of our users, what are their things of interest? And actually, if I think of the New York Times, what are our things of interest? We're interested in their phones. We're interested in their watches. Are we interested in their wearables? Are we interested in their refrigerator when it gets a display? Are we interested in a whole bunch of things? And sort of where is that overlap? What are our mutual things of interest? And as it turns out, as we think about the future, there may be many of these mutual things of interest. And so IoT is in our future now. I'm basically a platform provider, right? So I know IoT is in our future. I can see it. I've been around long enough to know that this is going to happen. Many of my colleagues at the New York Times haven't been around so long. They're young like you. And maybe they don't see it, but my job is to sort of anticipate and create a platform so that they can bring their creative ideas to it and use that platform, have it ready. We already know how to auto-scale. We know how to do lots of things. But one thing we haven't really quite figured out is how we can extend the fabric and go from a universe where we've got 1 billion devices to a universe where we've got 50 billion devices in a period of 5 years, where we're interested in some subset of those. So if we want to scale this architecture by 10 or 100 times, then what do? And my approach, based on my experience, is to make it simpler. Make it simpler, make it flatter. But where do we look to do that? Now, there's a protocol, which you probably haven't heard of, MQTT. It's an IoT protocol. It's simple. but it has quality of service associated with it. It's standard. Oasis made it as standard last year. And it's mature. That is, it's been around long enough that it's actually in use a lot of places. But who uses it? Anybody heard of Facebook Messenger? I think you've heard of Facebook Messenger. If you look, you'll see that in 2012 there was a lot of noise about them using MQTT, and then it went dark. But that's the backbone. Telemetry, there's lots of people, if you scratch around it, using MQTT. And there are a lot of open source implementations, servers, clients, and so on. So I'm not sure we'll end up with that, but this is where we're looking now. Some features of MQTT. It's got retained storage, and the session transcends connection. Wait, what do those things mean? These are things we had to code ourselves into our fabric. Retained storage means if you send a message and somebody's temporarily disconnected, you'll keep that message for them and deliver when they connect. Okay. Session transcends connection. That means pretty much what you think it means. It means that you can have a device that intermittently connects to the server, and its session continues through that intermittent connection. And and all that's built into the protocol, and the protocol describes clients, servers, and it has the wire protocol in between. So it's a complete set. So as we look at our messaging fabric, and we're messaging everywhere, then this looks fruitful to us because it lets me make everything simpler. Because all my client devices, and there are going to be a multiplicity of them, there's already code that exists for running MQTT on them. And it's a little simpler to use than some of the protocols that we've invented. And it's standard, so I can avoid some pushback and scope creep from my clients where they want to add a little bit because not allowed, sorry, it's not in the standard. So now we're going to dive into what is a message. If we're sending messages everywhere, and you can kind of think, well, things send events, and those are consumed by other things. We think of those things as being simple, but they may be complex. And so let's talk about an event then. And I pretty much think of an event as key value. The key is the topic. We're going to talk a lot about topics as I continue. And the value is a blob. We're not going to talk about it any more than that. And in fact, our platform really doesn't care. The payload, the blob, the value is opaque as far as we're concerned. We only look at the topic, and if necessary, we embed metadata in the topic. So we'll ignore the blob. But what's a topic? And just to highlight, and this is often a point of confusion in messaging systems, the topic, there are really kind of two flavors. There's the atomic topic where pretty much you subscribe to the topic, you publish to the topic, and it's not further subdivided. But then topics can also be represented as trees, and with a separator. Foo-bar-baz is an example of a published topic. I would publish to that topic, foo-bar-baz, and I could subscribe to it using either the same values or wildcards. So if I've got a wildcard, then I can use a plus to represent any level. In other words, I'll show you some examples. And I can put a hash at the end. This is the most typical way in which topic wildcards are expressed. There are other ways. RabbitMQ uses a different way, but uses different symbols, but the effect is the same. So if I've got this topic, foo bar bez, and then I get that I can match using these match statements, okay? Foo plus doesn't match. And the reason is there's no third term. Okay, okay, in that. Okay, well, so let's think about Cassandra, and I'll just make a statement here, and then I'll try to then I'll explain it. Cassandra, how it accesses data, I think of it as it hashes to a tree. Okay, and okay, I'm going to jump in the rabbit hole first. If you haven't done the courses on at the DataStax Academy, you should do them. They're really good, and they're free. And why not get certified? I did it. I learned a lot of stuff. I was surprised. I passed. It wasn't that easy. Okay, back out of the rabbit hole to this. So what's the hash part? The hash part, the partition keys take you to a partition. Okay, I think we can all agree on that. And operationally, you can kind of think of that as a big row. But what's the partition really look like? It's a map of maps. It's ordered by the cluster keys, right? Or you can think of it as grouped by the cluster keys. And in fact, it can be considered a tree. Okay, you can think of it as a tree that's been traversed. And that ends up being useful because we already saw that, you know, a topic is like a tree. And if a partition is like a tree, then maybe we can look for a way to relate those two concepts that's useful. So hold on to that thought. We've talked about MQTT. We're into wildcard topic queries. So what's that all about? The issue is when you use MQTT and you subscribe, okay, I'm up here subscribing, it sets up a match, okay, any current messages that come flowing along the pipeline, you'll get, but it also does a query. So MQTT acts like a database and gives you the last set of matches for your subscription, and your subscription can include wildcards. Okay, so there we are with a problem because we need to do this query. We want to do it in a way that scales. We want our whole infrastructure to scale, and we've got to handle an MQTT query. And the feature that does that is the retained storage. So this is the query I'd like to do. And oops, we can't do this directly in Cassandra, in Apache Cassandra, which is what we work with at the New York Times. We're sort of big on open source, and so we stick with the open source. So, holy jabako, this is an inside joke. Do the courses, get certified. This will make sense. But so how do we handle those wildcard topic queries? And we do it with query strategies that I'm going to outline here. So the query strategies need to be composable. But what does that mean, and is there anything like that already in Cassandra? And we'll jump in the rabbit hole. And if you think about the primary key, it's composed of partition keys, cluster keys, and it uses, Cassandra that is, uses composable strategies to access data. These are really very different kinds of things, but they're expressed in one portion of the DML, or the DDL. So the methods of doing And secondary index keys are similar and result in other composable strategies. That is, I can use them together to access my data. And so we're kind of looking for the same thing. Want our query strategies to be composable. We, of course, also want them to be efficient and predictable. So again, let's look at that query and think about strategies. The first strategy I came up with was to forget about it. Don't allow any wildcards. You know, let's jump back in the time machine again. And I went to lectures in about 1985, I can't remember exactly, by Edgar Dykstra. And his advice when you're presented with a project like this is kill it. That's the first thing you do. And if you don't know Edgar Dykstra and you're interested in computing, he was largely pre-internet, and so he's kind of lost to view. But everything you do in computing was in the mind of Edgar Dykstra by 1980. And so let's talk more about the strategy. Well, he also said start with the most risky, difficult piece first, and if you can't kill it, okay, well, we couldn't kill it. So strategy 0 is not enough because we want to be able to handle those wildcards. So we came up with a set of algorithms, which I call the cluster key shuffle. And it's a layer on top of Cassandra. It actually ends up getting expressed as a set of lookup tables, so it's very fast to do the right thing. But you basically shuffle your wildcards over to the right, and then you come up with ways of generating the code that you need. You do how many inversions, it depends on what data you're providing, and you're right, but it'll automatically do inversions for you, and so forth and so on. The problem with it is it's complicated, and it's really only good for 3 or 4 levels within our tree. But as it turns out, that's actually quite useful. Okay, so if a topic's a tree and a partition's a tree and we traverse and flatten them, well, that brings to mind another strategy, which you see a line through it here, which is the secondary index key shuffle. The problem with this is it's not performant. And I think maybe there's some hope in Cassandra 3. Actually, that's an area where I'd like to get in and maybe contribute a bit to Cassandra, because I've worked with databases all my working life. And so some of the strategies from Postgres or mature SQL databases could probably really help with this secondary index, with the secondary index performance problems that we have in current releases. So we'll scratch that strategy. But my third strategy actually ended up being very useful. And that is to look around and find some open source software. And I highly recommend that you check out Strat.io Lucene. They've got a presentation tomorrow at 2:40. And you can grab this man right over here, Andres, and he'll tell you all about it. But it basically was so simple. Just drop in the jar, and you're off and running. So you get new capabilities. So it was a lot easier than some of the other things that I had considered. So what about performance? Where are we on that? And okay, so no wildcard. Excellent performance, right? Because I can just, actually my topic can be a partition key and I can just go directly to it. Excellent on read, excellent on write. Cluster keys, actually excellent on read, single partition read. And it's okay on write. The number of inversions it does depends on how much data you're storing. So if you keep your hierarchy shallow, your tree shallow, then this can be a very high performance solution. Forget about secondary index keys. And Strat.io Lucene is okay on read and okay on write, and as far as we've been able to determine so far. So where do we go with this? Well, remember these strategies are composable. So if I've got a query, it looks like this. How am I going to break that down? And so one of my approaches, which is to just use Lucene. It's moderate complexity. Basically, we generate a filter with a regex in it, but by itself, it will hit all nodes for read, just a single node for write. How about no wildcards plus Lucene? So think of us going from left to right. This actually ends up being very useful because, for example, for the New York Times, we have a lot of stuff that's stored by user. Several million users. I know which user I'm going to. That can be my no wildcard part. You've got to provide that. Once you do, that gives me a partition. Within that, I can use Lucene to just go to that partition. Okay? Moderate complexity, single partition read and write. Okay, in this case, foo is what type of ID I have, bar is the ID. Okay, so I picked that off. No wildcard and cluster keys in Lucene. It's more complex because of the cluster key shuffle, but single partition for read, multiple for write, and it can handle these intermediate values, including wildcards. The stuff to the right gets handled by Lucene, but the stuff that I'm indexing in Lucene is a lot simpler than it was before because I'm not having to do the whole topic. I'm just having to do the parts to the right. So if we think about this again, we got down to the query strategies. We're going to go forward this time. It's kind of what kinds of things am I thinking about? Where are we going to go? And the things all exist out in the wild zone, and they come and go and come and go. But we have a highly available zone that we've created in AWS and with our own internal infrastructure. And so we're looking at moving more things to the edge of the network, to the blue boundary there. And so we think about things like creating a user proxy that's always available for every user in that zone. And it might be a real object, or it might just be the data or whatever, but the idea is to keep pushing to the edge. So those are things I'm thinking about. Other people are thinking about this sort of thing, semantic structures. We do a lot of analytical work. In this case, we have all the concepts that the New York Times deals with in a Titan database over Cassandra. This is my colleague Elizabeth, and I hope to get into there sometime. If we jump down the rabbit hole, and I can give you guys some advice, I think it would be this. It would be go where the excitement is. That's worked for me for my whole working life. Don't be afraid to jump down the rabbit holes and try things out. It's a great time to be raising money and bringing new ideas out. I've been through a number of revolutions. I've made a lot of money. I've lost a lot of money in the late 90s and turn of the century. And we're kind of in that same sort of time now. You look at the Internet of Things, and everybody's got a protocol. There's a lot of them, co-op, a whole bunch of stuff happening down at the network level. Get involved, learn about those things, pick a piece, and run with it. Think about how the Internet of Things impact, your organization, and use something like Cassandra to handle the scalability issues so that you can strike gold and just scale. So there's a lot of money washing around. You know, I'd get out there and go for it, or go for companies that have it and come up with those new ideas. That's about it. I guess if anybody's got questions and I can hear them, I'll be happy to answer. Anybody? Okay, we're good. Thank you. Oh, we had one.
Could you maybe just give a few practical applications of the sort of data you're pushing across, maybe MQTT,
Sure.
thinking about pushing across?
Yeah. So I've taken for example, the whole publishing stream that comes out of the New York Times, the Harry Potter novel, and I push it into an MQTT broker. And then then it's very easy to just sort of tack on little applications that read from that broker and invert things and do stuff. So I may make that data available by URL, by topic, by tag, all kinds of different ways in this wildcard format. And then a user, I can do this with my Raspberry Pi, you can subscribe to those topics by wildcard and get just what you're interested in. So maybe I only want to look at the watch, but I'm only interested in AP articles that appear on the watch. Then you can select that out. So the key for me is I built a platform that allows the developers and users to use that wildcard capability to get what appears to them to be almost instantaneous access, because it's right to the partition of interest, pulls it right out. And it's just a simple structure. So that's one way to think about the use of Cassandra. Another way to think about it is, oh, I got this global thing there. You know, this, by the way, is peer-to-peer network. We don't just publish and subscribe. We also gather and analyze. Okay, so I don't need any intermediaries. I've already got it all in Cassandra. It's all persisted in Cassandra. So I can have an analytics cluster somewhere that just drives directly. I don't need any intermediary to get it into my storage system of choice. Other ones are just sensor data. I mean, there's all the stuff you can grab off an iPhone or any phone, you know, location oriented, all this stuff. Is that useful? Is that useful for us, for the New York Times? And I would say, right now we're not using that, but 2 years from now, I think we will be using that. So we'll be looking for that mutuality of things of interest, and location may become one of those. You know, when you open the door to your house, is that when you want to see your breaking news, for example? I mean, how important is geolocation to us? It's getting more and more important. Tag everything. So I can think of lots of kind of applications, but I know that my colleagues back at the New York Times can think of many, many more that I don't. And they're driven by analytics, and I'm driven by sort of looking in the rabbit hole and seeing what I can imagine for the future, but making a general platform.